Hello, ladies and gentlemen. Today we're going to be taking a look at other relationships inside circles. So how are other angles going to be found using our circle facts? So for this, we're going to need that angles chart that you've been working on. So we're going to fill in our notes there, and then you're definitely going to need a calculator because we're going to be subtracting and adding some rather large angle degrees, okay? So here's what we have filled in so far. We have, if you have angles formed by two radii, or a radius and another radius, we have the angle will be equal to the arc across from it. And we've also filled in that when we have two chords, the angle is half of the arc across from it. But there's a whole lot of other ways that we can make angles, as you can see, and we're going to fill those in today. So what if the angle is on the circle but not made by two chords? So you'll see this is the one formed by tangent and a chord. So notice that the tangent and the chord make an angle down here, angle 1 and angle 2. Now, the angle will continue to be half of the arc across from it simply because the angle is still on the circle. The vertex is still located on the circle, so this angle too would be half of this intercepted arc, or the arc that's across from it. And the same thing for angle 1. This angle is still on the circle, so I look at the arc that's intercepted, or the arc across from it, and that will help me find my angle degrees. The angle is half of the arc, okay? So let's go ahead and fill that one in our beautiful circle chart. We're talking about the tangent and the chord. So the angle is still half of the arc. That should say arc right there. I don't know if you can see that on the screen, but angle equals half of the arc. And the picture for tangent and chord, again, pictures are lovely, they work, would be you'd have a tangent line maybe right here and a chord maybe right there. Oops, went a little bit too far. Chord stops on the circle. There we go. So we're talking about finding that angle that still has the vertex on the circle. And that was the same with two chords. The vertex was on the circle, so the formula remains the same, okay? Now let's look at some other situations that can happen. What about all the other possibilities? What about if we have two chords intersecting to make angles inside the circle? Notice that the vertex is inside the circle on this one. Well, when that happens, we're going to take the average of the two arcs. So we're going to add the arc on one side, add the arc on the other side, and divide it by 2. That's what it means to average the arcs across from the vertical angles, okay? What if the angle is located outside the circle? It can be made by tangents, secants, tangent and a secant, any combination. For that, we're going to subtract the arcs and divide by 2. Okay, so what we're talking about is that vertex is located outside the circle, like you see here, where the red dot is. The vertex is outside the circle, and it can be made by a number of different things. Like it says, tangents, two tangents, a secant and a tangent. So the rest of this chart, ladies and gentlemen, can now get filled in, okay? So when we have two chords, and they intersect inside the circle, so they look something like this. I would draw this picture, okay? It's not necessary that this vertex is in the middle. Here it is in central location, not necessary when you have two chords. Any two chords can intersect anywhere in the circle. And when we do that, the angle equals one arc plus the other arc, then divided by 2. So essentially the average. And the arcs that we'd be looking for are the arcs that are across from the two angles that would be vertical angles, okay? We'll do a few examples. Two tangents, two secants, secant and a tangent. Let's draw a few pictures here. Two tangents might look something like this. Here's one tangent. Here's another tangent. Here's the angle out here. When we're trying to find that angle, okay, we're going to do the same formula we would when we have two secants. Secants are lines that go all the way through the circle, okay? And let's say they go like this, and they go like this. Good job. There we go. And that vertex is outside the circle. Tangent and a secant. So tangent here. Okay, here's a tangent line. Secant line is a line that goes all the way through the circle. So maybe like this. Okay, so the pictures will help you figure out what's happening in the diagram, but the formula for each and every one of those is the same. The angle will equal the arc minus the arc divided by 2 for these, okay? Notice it's different than the other one. We're not taking the average. We're subtracting the 2 arcs and dividing by 2. Arc minus arc divided by 2. And those arcs that we're talking about are the arcs that are across from the angles. So again, oops, I had those animated in. Here we go. Let's use this to find the value of x. So notice where the x is located here. Okay, just watch along with these pictures and so you can see what's going on. The x is located here outside the angle, or outside the circle, my bad. It's an angle outside the circle. So when we're trying to find the value of x, first job is try to find out where that vertex is. What's the situation? And then refer to our chart to find that formula. So it says the angle will equal the arc, subtract another arc, divided by 2. So we need 2 arcs because our angle is labeled with an x here. We're going to need 2 arcs to subtract. So we're going to look across from this angle. One arc that I intercept or that I see is 42. And the other arc that I intercept is 78. Now if I subtract those, I'd want to take 78 subtract 42 because I want to make sure that I don't get a negative value here for my angle. So 78 subtract 42 and then divide that answer by 2. So 78 subtract 42 is 36. 36 divided by 2 is 18. So the x equals 18 degrees, okay? So we're taking a look at what's happening in the picture, where's the vertex, and then using our formulas from our chart to help us figure out the situation, okay? So I'm going to do a little erasing on this one because I wrote over the spot where the other guy was. Here we go. We have 63 degrees, 89 degrees, and we have an x degrees located right here. This angle is located in the circle. Is it in the center of the circle? The answer to that is no, it doesn't look like it, okay? So we're not going to use the central angle one. We're going to use the one for when a vertex is located in the circle. That is the angle equals arc plus arc divided by 2. So my angle is labeled with an x. Arc plus arc. Now if my x is here, and this would be vertical to it, so they'd be the same number of degrees, I have an arc across from here of 89, and I have an arc across from his vertical angle, which is 63. Those are the 2 angles you're going to add. 89 plus 63, those are the 2 degrees we're going to add, and then we'll divide that answer by 2. So 89 plus 63, and then take that answer divided by 2, and you should end up with 76. So 76 degrees is what that angle x is. Okay, couple more here. Let's get my line rotating. There we go. And one more. So here we go. Let's take a look at how that chart continues to help us, and then we'll be done. If we're going to find this angle x located right here, notice where the vertex is. It's on the circle. So when an angle is located on the circle, what is the formula that we use? We use the formula where the angle equals half the arc across from it. So the angle in our instance is x, and we're going to equal half of the arc across from it. So angle equals half. Who's across from it? 228. So half of 228, so 228 divided by 2 is 114. So angle x is 114 degrees. And now let's take a look at this last example. Notice where the x is here. He's an actual piece of the circle. So he's not an angle that we can just try to find here. We're going to have to use what we have in this diagram to help us figure out how many degrees that circle is, or that piece of the circle is. So here's what we do know. This angle over here is 118 degrees, and that vertex is located on the circle. So the angle that's on the circle is 118 degrees. That means when I look at the arc across from it, that has a relationship. If you remember, that relationship is right here. The angle equals half of the arc. So using that information, we would just take 118 times 2 now, and that tells me that this must have been a 236 degree piece of the circle. That is from A all all the way over till it hits the other side of the angle here, that piece is 236. But remember where the X is located? He's over here on the blue part. Well, how would I find that blue part? Well, that blue part would just be whatever's left out of the 360-degree circle after we take out that 236. So if we subtract 360 from 236, 236 from 360, we get 124 degrees. So from A to B, or X in this case, is 124 degrees. Okay, so we're going to be using that chart to figure out those angles or to find pieces of circles, and we need those relationships, okay? So keep that chart as a good reference. We're going to be able to use that in the future, and thank you for taking good notes.